What's going on, guys? As you already know, we're making a game like The Binding of Isaac. So if you have been following along, you should have a project that's like this one. If you haven't been following along, you can download this entire thing from the description of the video for free. So if you want to join in on making this, you're definitely welcome to. We're not too far into it. We're about to add enemy AI to the game. So we're going to be making our own AI system for the enemies. We're not going to be using like the nav mesh agent or any of the built-in Unity AIs. If you guys are enjoying the series so far, make sure you like the video and subscribe to the channel. And So I'm just going to show you this in Paint before we continue because it's really important you understand how it's going to work before we actually try to make it in Unity, right? So this is the enemy and this is the player and these are the walls on the edges, right? Let me just paint in this enemy red and we'll make the player black. And then inside of this, there's going to be an obstacle in the way right here, right? So we want to determine the quickest route for the enemy to get to the player without crashing into any obstacles. So we need something called a path. We can't go directly to the player because there's this box that's in the way. So we want to go a unit of distance at a time towards the player. So instead of like going all the way to the player, let's say this is like 100 or something, right? We just want to go like 5 at a time until we get to the player. So this would be a point on the path, right? So this is a point and this is a point. And then if we go 5 more towards the player, we end up hitting this box here, right? So when we run into an obstacle, what it will do is it will start penduluming back and forth. So like if this is the path that it's going in, it will go left and then right and then more left and then more right until it finds a spot where it can actually make the enemy go there without hitting an obstacle. So if it goes 5 degrees to the left, it's still hitting the box. And then it will try 5 degrees to the right, it still hits the box. Then it goes 5 more degrees to the left, and it finds a path where it's not obstructed, right? So it will do this, and then it will try to go towards the player again. It will hit the wall, and it will do the same thing, and it'll probably find a point like here, and then it will go directly towards the player. So like here, etc., until it gets to the point. So right away, when the enemy spawns into the scene, it's going to calculate a path to the player immediately, right? It's not going to go to this point and then find out the next point and then find out the next point. It's going to calculate all of these points and put them into a list, and then it's going to use the list to navigate towards the player. So this could get, you could have the enemy update its path every like 5 seconds or every couple seconds, or based on what kind of performance that you're looking at, right? So this is really simple. It's actually not that difficult. Using the built-in Unity AI is a little bit more complicated because you have to deal with things like acceleration and speed and turning and what direction is the character facing, and you have to add a nav mesh surface onto all of the surfaces in the entire game. And you have to determine what it does if the enemy gets off the surface, like if it goes into like outer space or something, right? You have to factor in all of these extra things. If you make your own AI system, you could just avoid all of that and just have it do this. All right, so now we're going to recreate what we just did in Paint in actual Unity, right? So at the bottom, like in the folder area, I've created a new folder inside of the prefabs folder called enemies. And then inside of that folder, I've created another folder called enemy1. Inside of this, we're going to right click and we're just going to create a material, and we're just going to call this enemy material. And then we're going to right click on room 0, which is our starting room. This is where our character starts, okay? And we're going to create a 3D object, and our enemy is going to be a sphere. Let's make it 5 by 5 by 5 in size, and let's drag it to the bottom left corner where we had our enemy in the paint drawing. And let's drag him a little bit up so he's floating above the ground. We don't want him to cast a shadow. So if you click on your sphere on the right here where it says lighting, you can turn off shadows so that it doesn't have a shadow on the ground. And then we don't want to receive shadows either. And we just want to make our enemy, actually, instead of him being lit, let's change this to unlit, and then just drag this on here so that he's just like a red circle. Okay, maybe we'll make him lit because it kind of looks a little bit weird. Let's actually just change it back to lit. So yeah, so if you've done this right, so you should have a sphere in the bottom left corner, right? And then let's move our player. So in the main folder, we have our character here. Let's move him to the top right corner for now, just because we want to build like the same, we're doing the same thing that we did in the picture that we already did. So we're going to be replicating this picture, right? So the last thing that we need to make this work is an obstacle. So let's right click on room 0 again. Let's make a cube. We're going to make this 15 by 15 by 15. And it can, yeah, it could just pull it above the ground a little bit. And we need a material for it because it's matching the ground right now. So let's create another material and we'll call this obstacle material. We're going to be probably deleting all these materials after I'm done. This is just for demonstration purposes, right? So let's drag the obstacle material onto the obstacle. And again, we don't want the shadow. So let's just click on the cube and turn off shadows so we don't have a shadow there. So if you've done this right, you should have your enemy in the bottom left corner, which is a sphere. And then you have this obstacle in the middle of the room. And then you have your player in the top right of the room. Okay, and there's one more thing that we need to make, which is going to be the points that are going to be part of the path, right? So if you right click in our room 0, we can create another 3D object. This is going to be a sphere. And let's pull it away from this. We want this one to be smaller than the enemy, but large enough we're able to see it. So let's just make it like 3 in size, and we want the color of the point to be black. So let's create another material, and it's going to be called point material, and we're going to drag this onto the point, and we're just going to make the base map black, and then we want to change the shadow to be off on this one as well. And inside of the hierarchy here, let's rename this to point, and we can drag the point into the bottom to make a prefab out of it. So the way this is going to work is while we're drawing this, it's so when the game starts, when we run the game, there's going to be a bunch of points that get generated just like we had in the drawing, and it's going to show the path from the enemy to the player. So let's make this actually a little bit smaller. So we can delete this from the scene now, but inside of our bottom part, just make this like 1.5. It doesn't need to be 3. 3 is too large. And we just are going to want to use this to actually show where the path is going to be to the player. So now we need the script that's actually going to draw the path, right? So we're going to attach the script to the enemy. Now this is not, again, this is not going to be the final rendition of this. This is probably going to be just a static method that we're able to use for, we want to be able to do this on all of our objects, right? Like maybe we have a heart that's flying towards the character or something else that's going towards the character. Maybe it's not an enemy. Maybe it's something else, right? We want to be able to generate a path for any object. But we're not going to be doing that today right now. We're just going to be going through the basics on how to get an enemy to draw a path from the enemy to the player. So we've got a sphere over here on the left. Let's rename this to enemy 1. And then we want to make a script that we're going to attach to the enemy. So if we right click at the bottom, we can create a C# script. And we'll call this enemy path script. So then inside of the enemy, we can drag the enemy path script onto the enemy. Perfect. So now that this is attached to the enemy, we need to double click the path script to open Visual Studio. And we're going to do the code for this. Okay, so here we are in the script, in the enemy path script, right? And we need to declare our variables that we're going to be using inside of this, right? So from our picture, the first thing that we need is the distance, right? So that is the distance between each point. We want to be able to change this in the inspector so that we can have more or less points. Now, remember that more points means that he'll more precisely evade the objects, like going just right around them. And less points means that he'll go further, like he'll it will be more performant with less points but more accurate with more. So we need the distance, so let's make that. So public float distance. Okay, and then we also need to save all of like the points into a list, right? So we have all these points that this is what we're doing, right? We're making like a path, and each one of these is a position, and to save a position we use a vector 3 for that. So we're going to be making a public list of vector 3. And it's going to be the path that we're going to be taking. Okay, and then we need to add the game object for our point into our script so that we're able to draw a point for every single point in the path. We actually want to visually represent this inside of it, right? So inside of the actual scene, when we're drawing these points, it should look like this, right? Like there'll be one here, and then one here, and then one here, and then one here, and then etc. until it gets to the player, right? So we need to have access to this so we can draw it in our game. So what we need to do is at the top here, we need a public game object. And you can just call this point. Okay, and then after you're done that, you can click on the enemy, which has the script attached to it, and you can drag the point into the point slot. Okay, so now we need to write the code that's actually going to make the path. Now you would think that the proper spot to put this would be the start method, because this happens once at the start. Like when this object is created in the scene, this happens right away. But unfortunately, the start method doesn't allow you to use raycast. Now a raycast does exactly what you think it does. So we have an object here. and we can cast a ray from the object in any direction, which in this case, it's going to be towards the player. And we can cast it for a certain distance, which in this case, it's going to be 5, and it will tell us if it hit anything. We need this method in order to do this, right? So you can't do this inside of the start method. And because of that, we can only do it in the update method. But the update method runs once per frame. So obviously, if we redraw the path in the update method, it will do this every single frame, which is way, way too much, and it will lag your game immediately. So what we need to do is we need to set it up in such a way where the update method, even though it's inside of the update method, it's only going to do it one time. So we're going to make a Boolean value, which is just going to be, the Boolean is just like a true or false value, right? And we're going to call it path drawn, and we're going to set it to false. And then inside of this update method, we're going to check if the path has not been drawn. That's what this little exclamation mark at the beginning means. That's the not operator. So if this is not true, which is, it is in this case, it's not true, then we want to call a method to draw the path. So we're going to type in void draw path up here. And then inside of this, we're going to set path drawn to true right away. So this only happens one time. And then we're going to call draw path. Now, the reason we're setting this to true first is because this runs every frame and it's really quick, right? So if this is not done yet and this hasn't been set to true, it could happen again, right? So because a frame could take, it's like a millisecond for it to finish. So we want to set this to true immediately and then do the code that actually draws the path. Okay, so we're going to start by raycasting towards the player. So if you're using my game, I have the player's transform saved here in this static class called player, but if you're not following my script and you're doing your own thing, you need to create another public game object for the player and drag it into, like go into Unity and drag it in or whatever, right? So the first thing we want to do is get the direction. So vector3 direction is the player transform position minus the transform dot position. Now, the transform position, the transform is the game object that the script is attached to, which is the enemy in this case, right? So we're taking the position of the player, which is in the top right corner, and we're subtracting the enemy's position, which is in the bottom left corner, and this gives us the direction. Okay, so now we want to actually cast the ray, right? So we need to create a variable for a raycast hit. And we could just call this RH or whatever you want to. It doesn't matter, right? And then if physics dot raycast, and then so this is being cast from the enemy, which is the transform dot position, in the direction which we got by doing this subtraction statement up here. Then we're outputting it to the variable. And then we're setting the max distance, which in this case is the distance. And at the top here, let's just set that this distance is equal to 5 by default. So we're checking if this hits anything, then it's no good and we need to do the remath. Otherwise, we need to add it to the list or draw a point at like the distance. Okay, so now I want to spawn a copy of this point at the distance. So if it didn't hit anything, we want to put a point because it's a valid spot on the path now, right? So we're going to create a point. So we'll just do instantiate point, and then the position is going to be the transform dot position plus the direction, which is normalized, times the distance. And the rotation doesn't matter, so you could do quaternion dot identity because it's our point is a sphere, so the direction of it doesn't matter. If you do have a point that's more complex, you could use the point to transform like rotation. So you could type in like point dot transform dot rotation. This will take the rotation of the prefab, whatever direction you have it saved in, and we'll do it in that direction. So if we've done this right, when the game starts, it should draw a point which is 5 towards the player, and it shouldn't, I don't think it will hit anything. Like, I don't know how big 5 is, but we're going to find out. Hang on. So currently you see that there's no points in the game. So if we run this, okay, so if we go into the enemy, we'd have our, because we set this variable to 5 afterwards. So we just need to change the distance to actually be 5 and just rerun it and should fix it. Okay. Oh, we have this completely upside down. Okay, it doesn't matter. So you can see that this is the point anyway. So it spawned this 5 away, and this is going to be our first point in the path that leads to our player. Our player did spawn in the... We had this completely rotated the wrong direction. Let me just fully flip these around so that they're in the right spot. Hang on. So let's put the enemy in the bottom left, and then the player can go in the top right. And then let's put the player here so you can see that it actually go towards the player. So like you can see that this is directly towards the player, and this is how the start of the path generation is going to work. So okay, so let's put this back here and we'll carry on. Okay, so as you can see, we've created the point or whatever, right? But we also need to add this to the list of paths because this is a successful point that we've actually added, right? So we want to add this. And we'll just put... So we're adding the vector 3, which is the position of the point, if it didn't hit anything. But if it did hit something, we have to do a recalculation, right? So if this failed, this shouldn't be an if statement. This should be a while statement. So let's take this else away for right now. And we're just going to comment this out. And we're just going to type in... okay, so we'll make a Boolean value here. Checking direction. And it's false. So you have to be very careful when you do something like this because you'll get a forever loop and it will crash your Unity, and then just make sure you save every time before you run this or whatever. So while checking direction, let's just make this true so that it makes more sense. So because we are checking direction, right? So then we want to do if it's the same if statement as before, right? So... And we can redeclare the raycast every time. And we'll just type in KF to format this. All right, and then we'll take this part and we'll put it here and we'll uncomment it. Then we can get rid of this. So this will keep happening until it's successful, right? So if this happens, then we'll set checking, actually before we even do anything like this, we can just set checking direction is false so that it can carry on. So the other thing we're gonna do is we're gonna make a failsafe. So we'll have an integer here called failsafe and it's set to 0. And every iteration of this, we're gonna increment the failsafe. If the failsafe is above 15, then we're just gonna break a return from this. So what this essentially will do is if you messed up your code down here, or if it doesn't find a path, maybe there's no viable path to get there. Maybe it tries like 15 times with the pendulum thing and it runs out of directions and there's no way to get there, right? And to get into a blank spot. This will eventually give up and we'll stop drawing the path altogether. We'll just return from the method altogether, right? Inside of here, if this hits something, we need to do something different, right? So right now the raycast is going in the direction. So we want to, okay, and I had to do a lot of this off camera because it took me a while to figure out how to make this work. So you're going to need to copy this entire method over again, right? I don't have time to go through everything, like type it all out while I'm explaining it because it's too much, right? So we're starting by getting the direction from the player to the enemy. From the enemy to the player, sorry. So the target is the first one and the position that we're going from is the second one, right? So then we're setting a variable called checking directions so that we can have a while loop. We have a failsafe and a counter. So the failsafe is to protect you from doing a forever loop because if it doesn't ever find a direction that it can go, it will eventually return from the loop. And then we have this. This is basically getting a number that goes from 0 to 5 to -5 to 10 to -10 to 15 to -15. So this is taking this counter, which is starting at 0. It's doing a modulus by 2, okay, which is basically like if you divide the number by 2 and the remainder is 0, then it will do this. Otherwise, it will do this. Okay, so it's that's what this question mark is. This is the ternary operator. So it's taking this number modulus 2, which is like dividing by 2, but it's checking if there's like a remainder after you divide it by 2. So like, let's say this number is 5. Modulus 2 would be a remainder because 5 modulus 2 is a remainder of 0.5, right? Because divided by 2 is 2.5, right? 0.5 is not 0. So it wouldn't do this to start with. It would do this to start with. So you could always export or output the result of this by typing in debug.log and then the result. This will output the result at the bottom so you can see it happening in real time. Then we're getting the rotation of this direction because we have a vector 3 direction here, but we can't add 5 degrees to a vector 3 because a vector 3 is a position. It's not actually a direction. So we're converting the direction into a rotation. That way we can multiply the rotation by the result of this, which would be 0, then 5, then -5, etc., right? And then we can set the adjusted direction to be the rotation times vector 3.forward, so the front of the object. So this is a little bit confusing, and this is why I did this off camera. If you copy this, it will just work. And then we're checking, so we're doing the raycast still. We're checking, we don't want an if and then else because there's nothing in the if statement at all. The only thing that happens is if we don't hit anything, then we do something, right? So the if statement, like the first portion of it, is not required. So instead of having if and then else, we just have this not symbol. So if this is not hitting anything, then we're gonna get the layer mask of everything except for the floor. Okay, so in my game, this dot or whatever, when it does like an overlap sphere, the plane is right there and will always hit it, right? So the plane is on the floor layer. So we're not checking the floor layer. We're checking for walls, we're checking for objects, but we're not checking for the floor, right? So we're creating a layer mask that has everything except for the floor layer in it for right now. Then we're doing an overlap sphere at the position where we think we're going to be putting the point. Because if this, like, let's say it's going back and forth, right? And it draws a point, so it tries right here directly towards the player, right? And it says no, and then it goes -5, and then +5, and then -10, and then +10. Well, when it gets here, it's going to determine that, okay, the raycast didn't hit anything, but the size of the sphere that we're drawing is like, let me just put it there so this will make more sense. Hang on. So the size of the sphere is not 0. So when it finally hits a point, which is right there, this needs to not be intersecting with the object. So even though the raycast doesn't hit it, this sphere does hit it. So we're going to be doing an overlap sphere on that position to check if the size of this point that we've made doesn't have it. So this is the radius. So when you use overlap sphere, you can see like the options in here. So we have the position, then the radius. So we're taking the lossy scale, which is the full size of the object, and we're making sure that it's not intersecting with anything. If it intersects anything, then we don't want to draw it. So if this overlap sphere count is 0, because it returns a list of colliders that it hit, right? It's not the same as the other one. It's not a true or false. It's returning a list of colliders that hit it, right? So if nothing, so the count is 0, if nothing hit it, then we're going to get out of this loop. But if not, we're going to carry on for the 15 attempts until it finally succeeds. And we're actually just going to make this 25 so it actually tries for a little bit longer. And this will keep, like, so if the sphere is too big and it actually intersects with that cube, it will try again. It will do like 5 more degrees. Okay, so you can see that I've put the sphere right next to this cube, and this is just for the demonstration purposes, right? So it's only drawing 1 point right now because we only have the one method being called. This method is going to call itself over and over again until it gets to the player, right? That's the whole point of it. So right now, you can see that, let me just get this point out of here because I added that manually. So if you run this, it should draw that point there. So you can see that like it determined that, okay, I can't put it towards the player, which is what we did initially, right? So it tried 5 degrees each direction, which you should be able to see here in this. Oh, did I delete that code? Oh no, I just didn't save it. Okay, let me save it and run it again. Yeah, so you can see it doing the pendulum thing at the bottom here, right? So it starts at 0 and then it does 5 and it tries both the ways, right? Until it gets to 35. At which point it determined that, okay, we've drawn this successfully. It's not touching anything. And yeah, so that's it for drawing that. So now we need to make this method repeat itself so that it's not just doing it one time, right? So we're going to make a new method called void draw point. And this method that we've already made this is actually the draw point method. This isn't the draw path method. The draw path needs to call draw point. And instead of the direction being from the player position to the transform position, this is going to take in a vector 3 current point, and this instead will be current point. So then in the draw path method, we can call draw point, and then we can type in transform.position as the input. So when this is done, it's going to call itself again, right? So you could do draw point, and the draw point will be drawing a point from the next position, right? So wherever this point is, so that's going to be, we could just do path.last. So path.last, so the last value in the path will be the point that we just added. And then we'll call this again and again and again. Now, if we raycast and it hits the player, we need to stop, because the thing is that this is going to cause an indefinite loop. And you need to be very careful when you're using the while loop, because you can really mess things up. So, or you're calling the same method again and again, because right now, this will go forever. So like, let's say we get to a point where it's at the player already, it will still try to raycast towards the player. I guess it will try 15 times or 25 times and give up, because it won't be able to, the player will count as a hit. So if this doesn't hit anything, then that, else if rh.name.transform stickman wizard, make sure you make this whatever your character is, right? Then we want to okay, so if the raycast hits the stickman wizard, then we're just going to exit out of this. This will still, but it could still go on forever. We need another protection that protects this one from drawing too many points. So we need to make a integer point limit, and we'll just set this to 0. And then every time this runs, we're going to increment the point limit. And if the point limit is greater than 50, then we're just going to return. So this is not the same failsafe as this while loop, okay? Because this, so let's say it's drawing a point, right? And it doesn't hit anything because it's on the player already, but it doesn't hit anything and it draws another point. Well, if this keeps happening over and over and over again, we need this to block, because we're calling draw point from draw point. So this really, really protects you from having a forever loop. I don't think this would ever happen, because if it gets to 25, like it should be hitting the player, which would cause it to, I don't know. Anyway, this should probably work. So draw point calls itself. So draw point, we're drawing a point from this, and then it will keep going and going and going, and it should make a path to the player. Let me just save this in case it crashes my game. Hang on. Okay, so for some reason it didn't make it to the player. So let's move our little cube enemy guy or whatever, move the enemy back to the bottom left corner, and yeah, just like that. And let's hit play again. Okay, and the reason this isn't working is because these sphere colliders are colliding with themselves. So what we need to do is we need to go into the point itself, and we need to delete the sphere collider. We don't need a collider for the points. They're just imaginary things. They're not in the final release or whatever. We're obviously not going to be drawing the points on the screen unless you want to do that. But yeah, this should hopefully fix it. Let's see if that's why. Okay, so it just says 0 a bunch of times. So that's good. So let's go back to the code for a second. So we're drawing a point from the transform position. So the transform position is the current point. So that's the enemy and that's the player. So it's the player minus enemy. Okay, so let's do debug.log attempting to draw point. And then we'll do point limit, because point limit is getting incremented every time we run this. So let's see if it gets past 0.1. I don't think it is. I think it's only doing 0.1 for some reason. Oh, I know what the problem is. Okay, so we probably use the transform position in some of this. Let me just see. Transform. Yeah, so we're casting a raycast from the transform position. We don't want to do that. We want to do it from current point. So like that. And the overlap sphere should be that as well. All of the spots where we've put in transform.position, we just need to replace that with current point. And I think that should do it. So now we'll have the added debug where it tells us what point we're drawing or whatever. So let's see. Excellent. Okay. So it's still messed up because it looks like it never ended up hitting the player. And it could be because the player's on the default layer, but you can see that it drew a line from the ball, or the enemy, I guess, to our player. So that's really cool. Now, why didn't it hit? Oh, because the overlap spheres. If vector3.distance player.transform.position, comma, current point is less than 5, return. Okay, so now we'll check if the distance to the player is too close, it's just going to return. All right, there we go. So this is exactly what we were looking for. And you can see the numbers of the points that are getting drawn here. So 14, 13, 12, etc. Right? You can see how many points have been drawn. So there's like 23 points. And so this enemy now essentially has a path that it can follow to get to the player. And this is all the time that I have for today. In the next video, we're actually going to be making the enemy follow the path towards the player, and then we're also going to be doing something where it can go through this list, right, and it can find if this starting position has nothing, like if it casts a ray between this enemy and each point and there's nothing between it, it can delete the points. So like, for example, in this case, it should go from the enemy to this point instead of going like this along the thing. And we can set something like that up. I'm not sure if we're going to do that in the next episode. In the next episode, we're probably just going to make the enemy actually go down the path and chase the player around or whatever, right? But yeah, this is how you can set up your own like little pathing system. And I would definitely recommend this over the nav mesh, because if you don't understand how it's working, like there's so many different ways that the enemy can behave. But yeah, anyway, if you guys are enjoying the series, make sure you like the video and subscribe to the channel, and hopefully I'll see you guys in the next one.